Hello, I'm Holly Harris, Sustainability Coordinator of Earthshift Global. Welcome to the Practical LCA Training Lab, Module 1, Sustainability Overview in Life Cycle Thinking. The precise meaning of sustainability and what it embraces varies depending on who is using it and in what context. However, some of you may be familiar with the 1987 sustainability definition from the UN report created by the World Commission on Environment and Development, which states it as development that meets the needs of the present without compromising the ability of future generations to meet their own needs. Here are the three pillars of sustainability: environmental, social, and economic. The environmental pillar includes natural resource use, environmental management, and pollution prevention. The social pillar encompasses standard of living, education, and equal opportunity. And the economic includes profit, cost savings, and growth. There is a need to have indicators within these three pillars. You need to be able to qualitatively and/or quantitatively measure each of these areas in order to improve the sustainability of your product, process, or service. One environmental metric is life cycle assessment, or LCA. A social metric is SA 8000, which is a social audit. Economic metrics include material flow analysis and life cycle costing. Spanning all these three pillars is the Sustainable Return on Investment methodology, or SROI, which is designed to examine a decision-making process from the viewpoint of multiple stakeholders while maximizing returns for as many of them as possible. This methodology brings life cycle assessment results together with social and economic impacts to create a unified assessment of the decision. This lab is going to focus on the environmental pillar of sustainability, specifically on LCA as dictated by the ISO 1440 standards and guidelines. The growing concern over sustainability is affecting public opinion, political legislation, and industry goals. Society needs ways to determine which actions are the most environmentally friendly and which are not. Organizations have been turning to life cycle assessment because it is a science-based approach to looking at green. LCA anticipates environmental consequences and lets you detect aspects of a project or a product that are problematic and find areas where you can develop better alternatives. LCA allows us to measure green and to look at environmental trade-offs to make sure that we are not trading one problem for another. As the sustainability movement defines itself, LCA is helping firms stay ahead of the wave of consumer preferences. LCA is scientifically robust. The ISO standards and guidelines allow you to see trade-offs but do not make decisions on which is a right or best choice. LCA is not meant to be absolute. You are measuring the relative possibilities of something happening. What is life cycle assessment? All products and services have life cycle phases where energy and resources are extracted and emissions and waste are created. LCA is a scientific method for analyzing the environmental impacts associated with the life of a product. Life cycle assessment is an established methodology to evaluate environmental impacts over the entire life cycle. It is credible, scientific, and comprehensive. The first ISO standards were published in 1997. They are the ISO 14040 Principles and Framework and the 14044 Requirements and Guidelines. We recommend that you read these standards. LCAs are being done around the world. In 2002, the United Nations Environmental Program and the Society for Environmental Toxicology and Chemistry, more commonly known by its acronym CTAC, launched an international life cycle partnership known as the Life Cycle Initiative to enable users around the world to put life cycle thinking into effective practice. Historically, LCAs have been used to improve the environmental performance of a product during its life cycle. In other words, From where are the majority of the impacts coming, and how can we reduce them? LCAs are also used to inform decision makers, strategic planning, priority setting, process design or redesign. In addition, LCA is used for selection of relevant indicators. It used to take 2 years to do an LCA from scratch. Instead of doing an LCA for every product, companies would do an LCA on one representative product and then create rules of thumb for the development of all their products from the LCA. For instance, in the electronics industry, the majority of the environmental impacts occur during the use phase due to the electricity used or batteries consumed. In addition, the manufacturing of integrated circuits generates significant impacts in the toxicity categories. These rules of thumb help practitioners select relevant indicators for their products. More and more, LCA is being used to support product certification and marketing through environmental claims and eco-labeling. Please note that LCAs intended to be disclosed to the public require a critical review according to the ISO standards. The ISO standards state that in order to decrease the likelihood of misunderstandings or negative effects on external interested parties, a panel of interested parties shall conduct critical reviews on LCA studies where the results are intended to be used to support a comparative assertion intended to be disclosed to the public. In other words, if you want to say publicly that your product is environmentally superior to another product, you need a third party to review your study to make sure it is backed up by science. People's livelihoods can be affected by statements like these. Consumer behavior can change because of statements like these. So according to ISO, if you are going to make a claim about one product being better than another, it must undergo a critical review. What do I mean by a critical review? A third party will read your report and make sure that it follows the ISO standards. There will be a revision period where the study may be revised and resubmitted to the third party for another review. The critical review process provides reassurance to the commissioner that the study was done correctly and presents quality information, as well as providing reassurance to the readers that the results presented are backed up by science. In addition, it provides solid substantiation against claims of false advertising or greenwashing. The business case for LCA can be classified into 4 areas: increase revenue, build a competitive advantage, reduce cost, and identify risks in supply chain. Increase revenue includes responding to B2B and B2C preferences, as well as sustainable innovation. Through LCA, you can build a competitive advantage by attracting and retaining the best employees, appealing to customers and investors, and enhancing brand reputation. In addition, companies can reduce costs by identifying materials, energy, and resource hotspots, as well as costly redundancies. We worked with a company that had a sanitation process in their product. They were using both chlorine and hot water, which is unnecessary. Only one method is needed to safely sanitize. LCA allows companies to mitigate risk from materials and processes of concern and help prevent potential public relation crises. One client found one of their product components that made up only 1% of composition is 99% of ecosystem impacts. This may not be a big deal now, but a hot spot like that are areas for potential risk or regulation. It's pretty common to think that bio-based materials are environmentally preferable to synthetic or petroleum-based products. Just assessing one metric, the bio-based content can cause problems. In order to grow the material needed for the bio-based products, there is land use involved, and fertilizer and pesticide application, and fuel consumption from farm equipment. This takes away from crops being grown for food. That's why with LCA, we look at multiple indicators. The same goes with recyclability. If it is recyclable, is it sustainable? Sometimes the question is more complex than it seems at first glance. Paper, for instance, is recyclable, but it takes a lot more energy to create recycled paper than to make virgin paper. So, which is better? LCA allows you to look at multiple impacts so you can start to see trade-offs between land use and energy use, for example. We worked with Danisco on a project research in making xylitol using pulp instead of corn. Xylitol is a sweetener often found in chewing gum. Danisco is researching making xylitol with a pulp and paper plant. The pulp and paper plant typically produces a wayside stream that has a high carbohydrate content and energy value. The side stream is usually combusted to produce heat and electricity, which is used internally to fuel the pulp production within the plant. Instead, Danisco is researching using that side stream to make xylitol. Through an LCA, Danisco demonstrated the environmental superiority of their process of xylitol production. Their concept had significantly fewer impacts. The study was critically reviewed, and Danisco went to the market with their findings. Becton-Dickinson compared the environmental impact of current sharps collection disposal methods to the BD Ecofinity Life Cycle Solution, or BD recycles sharps waste and utilizes the materials to manufacture new products rather than disposing them in landfills or incinerators. They used LCA to evaluate their idea. This idea had fewer impacts than other sharps collection disposal methods, and they moved forward with the project. Other places LCA is being used include countries like France to begin requiring environmental labels on consumer products, the development of product category rules, and environmental product declarations. Big corporations like Walmart are requiring suppliers to demonstrate improvements in their environmental footprint. LCA has been incorporated into the LEED building standards. The U.S. Department of Energy is requiring LCAs for biofuel grants. There's an increasing concern over water footprint, that is, how much water is being consumed, what type of water, and from where the water is being drawn, and what effect that is having on the region. There's an increasing concern of waste management and extended producer responsibility. So, what is life cycle assessment? All products and services have life cycle phases where resources are used and emissions are created. LCA is modeling these phases from cradle to grave. If we were to consider the life cycle of a container, a plastic Tupperware container, the cradle will be mining the petroleum from the ground. Then we would process it into plastic. A manufacturer would make that into a container, which would then be shipped out to a distributor and retailer. The container would have a use phase where there might be some cleaning and some washing, for instance. Then, after a certain number of years, the container would be disposed of and a whole waste management stream begins. This stream might include some reuse, some remanufacturing, or recycling. Some containers might end up in a landfill or incinerator. During each step along the way in the life cycle of this container, natural resources are used and emissions are released into the air, water, and soil. LCA adds up all the resource extractions and emissions, so you have to think beyond your factory or company walls. For homework, please jot down some ideas about what is involved in making a cup of tea from a life cycle perspective, from cradle to grave, from raw material extraction, manufacturing, use, and disposal. This concludes Module 1, Sustainability Overview and Life Cycle Thinking. The next session in this series is Module 2, Goal and Scope Definition.